The tuples in a relational database are independent of each other, so we can actually introduce parallel processing. There's a nice book. I can only advise you, you software developers, to read it. It's a hardware book, but 60% of the book is marked as good for software and 30% is marked as mandatory for software developers. It's Hennessy and Patterson, I think, and the latest version of that just came out. And you can find there a portion where they talk about how establishing parallelism and how to work with multiple cores. And there is an easy answer. You have to find parts of the application where the application is for a long time doing the same and the exactly same thing. And then you are probably able to split it up and delegate it to multiple CPUs. Otherwise, if you do more complicated things, the synchronization of parallelism is pretty grim. It's not that easy. And therefore, success in parallelization is modest and zero, basically, in our applications. I can already tell you the one which is the classic one here for parallelization is the scan of a column. This is totally sequential going along this spaghetti, uncooked spaghetti. And since we know exactly how long the spaghetti is, we cut it like in the kitchen, click, 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 into pieces, and then we give every single core we have. If we have, for example, I would come to this in a second, 16 cores, then we can cut it in 16 pieces, feed the 16 cores parallel, and synchronize in the end only when they're all done. Since they do exactly the same, they will be done in more or less the same time. Then we have to join the result set, and we have a heavy parallelization of the most expensive task we have in the system. It's a little bit more difficult when we talk about joins and other operations, but this is the basic principle. Walking along a string, we know we do exactly the same now from here to there in the string, and therefore we can easily partition it.